Hello guys, in this video I will explain how ring-fence cipher works, and actually I will implement the cipher and decipher in Python. So how this works: at the beginning we have a clear text. The clear text is the text that we actually want to cipher, okay, and in this case is hello world. We get a key. The key is always a number, and in this case I choose this number. You can choose 4, or you can choose 6 or 2, for example. Why we need this key? You will see in the few slides. Okay. We must count the number of symbols in the clear text, and we get the 12. H, E, L, L, O, the empty space, W, O, R, L, D, and the exclamation mark. Okay, 12 symbols. Now we have two numbers, 3 and 12. With these numbers we build a matrix like this, with 3 rows, the number of you find in the key. If you have a key of 4, we will have a matrix with 4 rows, and the 12 columns, sorry, is the number of symbols. So let's start cipher. At the beginning we get the first symbol, the H, and put it in the first position of the matrix, like this. Next we get the E, and we put in the second row at the second column position. The L in the third row and third column. Now we have some kind of zigzag. As you can see, we are returning back to the first row. O, the empty space actually, and the W and the O and R, L, D, exclamation mark. So we do a zigzag like this, as you can see. Now we will take the first row and get this symbol and this symbol and this symbol. Let's see. H, O, R. We go to the second row and do the same. E, L, empty space or white space, sorry, O, L, and exclamation mark. Next we go to the third row and again L, W, and D. We ignore these empty positions, okay? So we add a clear text that says hello world, and we have a cipher text that says RL something, okay? In this, because this is a very simple example, this is pretty obvious, okay? If you have a big text, it will not be very obvious, I think. So let's go to the implementation in Python, the cipher. Here I have already set up the main program, and we have here a main. Hello world, the key is 3, and I call the function called cipher, where I pass the clear text and the key. So let's go here. So this function is empty. Okay, let's implement it. At the beginning, we will build a matrix. Matrix is equals to a list of lists. What the inner lists have is empty strings in range of len clear texts. Okay, for y in range of key. So in range of key. So we have a matrix that is actually a list of lists with the dimension of the inner lists are the length of clear text, and the dimension of the outer, the main list, is the key. That is the number 3. Okay, we declare a variable called increment. We have a row that is 0 and a column that is 0, 2, and we will go for each char in clear text. Oops, let me go. For each char in clear text, what we do, if the row plus increment is less than 0, or the row plus increment is greater or equals to the len of the matrix, this means that we are going out of our boundaries. So we do increment is equals to increment multiplied by -1. What this does is, if we have a 1, this goes to -1. If we have a -1, this goes to 1. Okay. Next we go to the matrix at row and column, and we set the char. Okay, 𝗀𝘂𝗁𝘁. We increment the row increments and the column too. The column can go whenever we want. Why? Let's go to the slide. What we are doing is the column is going in this direction and the row is going in this direction. when we go to the boundary, we switch the increment and we start moving in the other side, to the other side. Okay. Next, we did this out of the for. We go to the for each list in the matrix. We say that the result is equals to result plus empty string join list. We are getting the each char. We are picking each char, non-empty char, and concatenating each char. Okay. So if we run this, cipher text is, let me see if it is equal. Yes, this is the cipher text. Okay. Now the decipher. The decipher is a little more complex. Let's see the slides again. So we already ciphered the text, and now we want to get the clear text again. So we need the key. The key is very important because if we don't have the key, we have to try and we'll never get something useful. So in this case, the key is the number 3. So we build again a matrix with 3 rows and 12 columns. We have to kind of reverse engineering zigzag. So what I'm saying is we have to guess the positions. Okay, so we do the zigzag path like this. Now we know the positions of each symbol. Okay. We will fill that positions with the chars of the cipher text: the age, the o, the r, l, el, empty white space, sorry, o, l again, exclamation mark, l, w, and d, like this. Now we have to do a transpose the matrix like this. Is moving the matrix in this kind of, you know, as if you didn't already guessed, now we will get the chars like we did in the first case, the cipher. So we get the age, the l, o, white space, 𝗀𝗄𝗯𝗃 and exclamation mark. It's simple like that. The explanation, obvious. The implementation is a little more complex. Okay, so let's see how to implement this. Right on here, let's go here. So at the beginning we build a matrix like we did in the first case. I will copy this and switch this. We receive a cipher text and a key. Okay. Next we declare index is 0, increment is 1, and well, there is other ways to implement this algorithm. I implemented in this way, but if you like, you can do like I explained in the presentation, marking the positions and after that fill that positions with the chars. For each selected row in the range of 0 and len of matrix, for each this position we have a row that is 0, and we go to for each column in the range of 0 and len of matrix at row. We must check the range if we are going outside of the boundaries. So row plus increment minus 0, increment is less than 0, or row plus increment is bigger than len matrix. We are out of our boundaries. We must switch the increment symbol. Minus 1. Okay. If the current row is actually this selected row, we go to the matrix, add row and column, and we concat cipher text at index. The index was declared here, okay, before everything. Next we increment the index by 1, and outside of this if we increment the row with the increments. Okay, like this. We good to go. We go outside this 4, we go outside of the outer 4 too, and here we say that the matrix is equals to transpose matrix. This transpose is a function that already built is here. As you can see, is just simple as that. We receive a matrix and we build a reversed matrix, and actually we go for each position of the new matrix, we assign the reversed the value of the reversed position. So why we have a j I and I j like this. Okay, let me so we transpose the matrix, and for the last thing we do a for each list in the matrix. We do the same thing that we have done in the cipher, that is concat the elements like this. So let's see if this works. It doesn't work. Okay, let's see why. At line 50, what I have did. It's because inconsistency of the space and tabs. I like Python, but this is very let's see if it was the problem. No. I think I know why. It's because of this. And yes, now we have the same error at line 72. I think I did this with the white space and not the tab. Yes, okay. So we have original text, hello world. We cipher the text, we get this ORL something, and we decipher it again like this. So thanks for watching. Hope that you get it, and see ya. Okay.